Hello friends, as Albert Einstein rightly said, education is what remains after one has forgotten what one has learnt in school. Myself, Tushar Patel, Assistant Professor from the Department of Civil Engineering from the College Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, would like you to welcome all to the next topic, Airport Engineering. Today's topic will be Introduction to the Airport Engineering. Now, these are the contents of today's topic. We'll first look out the advantages and disadvantages of air transportation. Then we'll look into the history of aviation. Then we have the three bodies governing the air transportation, that is ICAO, AAI, and DGCA. Then we move across to the airports in India. Next is the classification of airports and the component parts of an aeroplane. And lastly, we'll study about the air characteristics. Now moving across to the advantages and disadvantages of air transportation, let us now look into some of the advantages of air transportation. As we all rightly know, due to its high speed, it saves energy and time. Air transportation mode is continuous over land and water without the loss of time, unlike the road and the rail networks. It helps in the economic growth of the country, faster development and distribution of product and services. Air transportation has the unique ability to open up any region that is inaccessible by the other means of transportation. Opportunities of foreign tourists for adventure during vacation. It's boost tourism. Bringing social changes by uniting people closer. It helps in better understanding of inter-religion problems. It helps in providing relief operation in emergencies like tsunamis, earthquakes, floods, etc. Airport generates several jobs and increases the value of land around them. Now, major disadvantages are it is very high in expense, including the cost of vehicles and traffic control systems. This mode of transportation has very few passengers and small cargo. Thus, the freight charges are comparatively very high. The weight carrying capacity of an aircraft is lowest amongst the other carriers of transportation. It requires highly sophisticated machineries. The weather conditions greatly affect the operations of air transportation. The accidents of aeroplanes are peculiar and alarming in nature. It has led to the psychological fear among the passengers about the safety of air travels. Regar Bacon was the first man who studied the flight of birds and made a prophecy in 1266 that the source of energy for the flight can be derived from fire. In 1909, the first flight it was made by a bicycle repairman named Orville Wright in a power-driven aircraft which was heavier than Trip. He propelled himself through the air a distance of 35 meters in USA. Now, during the period of 1914 till 1918, technical development of aircraft and engines in terms of dependability and load carrying capacity accelerated, partly due to World War I. In 1918, the first international air services started in between New York to Washington. In 1929, it was in India that regular air flight was started between Karachi and Delhi by Imperial Air Services. In 1927, May, the first longest flight of over 4,500 kilometers was undertaken from New York to Paris. In 1939, it was the first jet flight to be flown in air. And in 1952, till we reached 1950s, it was that a full-scale commercial service started using the Boeing 707. Now we come across to the International Civil Aviation Organization. In 1944, the delegates from 52 nations met in Chicago, USA to consider the problems of international civil aviation. It was then at that time it was created by the April of 4th, 1947 at its headquarters, Montreal, Canada. It is a specialized agency of UNO, United Nations Organization. ICAO had some aims and objectives. Some of them are to ensure safe and orderly growth of international civil aviation throughout the world, to encourage the art of aircraft and design and operation for peaceful purposes, to promote the development of airways, airports, and air navigation facilities for international civil aviation, to meet the needs of the people for the world for a safe, efficient, and economical air transport, to prevent economic waste caused by unreasonable competition, to avoid discrimination between contracting nations, to promote safety to flight in international air navigations, and to promote generally the development of all aspects of international civil aviation. Now moving across to the Authority of India, that is Airport Authority of India. Now the Airport Authority of India was constituted by an Act of Parliament and came into its being on 1st April 1995 by merging National Airport Authority NAA and International Airport Authority of India IAAI, forming AAI, that is the Airport Authority of India. The merger brought into existence a single organization entrusted with the responsibility of creating, upgrading, maintaining, managing civil aviation infrastructure both on the ground and airspace in the country. Some of the major functions of AI are: AI designs, development, operation, maintenance of international and domestic airport and civil enclaves. It controls and manages of the Indian airspace extending beyond the territorial limits of the country as accepted by ICAO. Construction, modification and management of passenger terminals. It helps in the development and management of cargo terminals at international and domestic airports. It helps in expansion and strengthening of operation areas such as runways, aprons, and taxiways, and many other things. The provision of visual aids have been looked by the AAI. It helps in the provision of communicational and navigational aids such as ILS, DVOR, radar, etc. Now moving across to DGCA, that is Directorate General of Civil Aviation. Now it is a regulatory body in the field of civil aviation. The post of DGCA was established in 1945. It has many functions. Those are regulations of air traffic services, licensings of pilots, registrations of the aircrafts, licensings of the aerodromes, approvals of traffic schedules, monitor flight crew standards, and the supervision and the training of the pilots. Airports in India. Now, as we all know, in today's world, international airports in India are about 34. In this figure, you will be able to see the international airports in India. We have around 486 domestic airports, a total including all the airports, airstrips, flying schools, and military bases that are available in the country. 131 total operational airports, that is 106 with the scheduled commercial flights, including some with dual civilian and army use. Before moving to the classification of airport, there are two terms which have different meaning, but it is misunderstood by every one of us. These are aerodrome and airport. Now, what is an aerodrome? A defined area on land or water intended to be used either wholly or in part for the arrival, departure, and surface movement of an aircraft. It is known as aerodrome. And what is an airport? Any aerodrome at which a permanent custom and immigration facilities are provided. It is known as an airport. The first aerodrome was built in UK in 1910, and the first modern airport was built in Germany just before the Second World War. Now moving across to the classification of airports. Based on the function, airports are classified under three categories: heliports, STAO ports, and conventional ports. Heliports meant for helicopters, stool ports meant for short takeoff and landing, and the conventional meant for normal commercial aircrafts. Now, based on the usage or the ownership, it is divided into four: public, private, military, and both. Public, owned by the government; private, owned by the individuals; military, used for the military purpose only; and joint use, used by both the civil and the military aviation. Based on the facilities available, number and type of the runway, and based on navigational aids. Lastly, based on the type of aircraft, it has four categories: BU, that is basic utility airports; GU, general utility airports; BT, basic transport airport; GT, general transport airport. Now, what is BU airports? These accommodate single engine and light twin engine aircrafts. GU accommodates medium twin engine aircrafts under 5,670 kilograms. Basic transport airport, it handles businesses jet under 27,200 kilograms. And general transportation accommodates anything that flies. Now moving across to the components of an aeroplane. As a schematic diagram of the aeroplane shows, the chief parts of an aeroplane are the engine, the propeller, fuselage, wings, three controls, flaps, and tricycle undercarriage. Now in this figure you will be able to see other parts as well, such as the cockpit, horizontal stabilizer, the vertical stabilizer, radar, elevator, ailerons, spoiler. These are the major components of an aeroplane. Moving across to the engine, the main purpose of providing an engine to the aircraft is to provide the force for propelling the aircraft through the air. There are four classifications according to propulsion: piston engine, turbojet, turboprop, and rocket engine. Now, what is piston engine? These are the conventional type of aircraft engines which are suitable for operate at low altitudes with medium speeds. In this type of system, the engine rotates the shaft with a considerable amount of torque. The propeller is mounted on the shaft to absorb that torque. When the rotating propeller attained its rated speed, huge masses of air rearward, thereby pulling the aircraft forward and creating lift on the wings. Turbojet. In this type, to start the machine, a compressor is rotated with a motor. As the compressor gains its speed, it sucks in air through the air intake and compresses it in the compression chamber. The air is ignited here by a fuel or kerosene oil. The expanding gases pass through the fan like blades of the turbine. The compressor rotates at the same speed as the turbine because the two are fastened solidly with one shaft. These hot gases with the remaining energy escapes through the tailpipe, which becomes smaller in diameter at the exit end. These then the hot gases have high velocity, give a forward thrust to the engine. It has been reported that the exhaust gas coming out with a speed of 1600 km per hour may push the plane with a speed of around 800 km per hour. Next is the turboprop. It is similar to the turbojet engine except that the propeller is provided in it. The main difference is in the design of the turbines. Last is the rocket engine. All the engines described are required oxygen to support the combustion. Thus, they can fly up to a certain altitude where sufficient oxygen is available. But the rocket engine, there is no limit to the altitude since oxygen in the atmosphere is not relied upon for the combustion. The engine carries its own supply of oxygen. Next, moving across to the propeller. Now see in this figure, these are the propellers. What are propellers? It is provided in the conventional piston engine as well as in the turboprop engines. It has usually two or more blades which are driven round in a circular path. The blade deflects the air backwards with an acceleration and thus forward thrust is imparted to the aeroplane. Next comes the fuselage. What is fuselage? Yellow color in the aeroplane shows you the fuselage. In simple terms, it is a main body of the aircraft consisting of pilot's cockpit, space for the passengers, the cargo and the tail. This combined is known as a fuselage. Next we come across to the wings. The aeroplane may have a simple pair, double pair, triple or quadruple pair of wings. The standard plane in the monoplane having one wing on either side of the fuselage. The purpose of an aircraft wing is to support the machine in the air. When the engine has given it is necessary forward speed. The term aerofoil is used to mean a wing-like structure which may be flat or curved and is designed to obtain reactions upon its surface from the air through which it moves the wing slightly curved in a section and are set at a small angle of incident to the horizontal. Three controls. Now what are three controls? There are three axes on which an aircraft in a space may move. These axes and the possible aircraft movements are shown in this figure. You may be able to see the axes, right? See the axis, your axis in the downward direction, the roll axis in the forward direction and the pitch axis in the other direction. It all has some or the other functions. The movement axis about the x is known as the rolling movement axis. The movement on the y and z are known as pitching and yawing respectively. To control these movements in the airplane, it is provided with three principal controls such as the elevator, the aileron, and the radar. Here are the three controls which then, if required, controls the three principles that are known as the yaw axis, the roll axis, and the pitch axis. Now, what are elevators? Elevators are to control the pitching, up and down movement. It controls during the takeoff and the maneuvers. It helps in loosening speed and turning. Radar, it controls the yawing. It controls the flaps that are used for going sideways. Provided at the tail, it can move around 300. Ailerons. Now what are ailerons? These are the provided rolling motions. Hinged flaps, one wing rises, the ailerons on the other wing goes down. Enables the pilot to restore its level to flight when it is tilted by a gust of wind. It stabilizes the plane. Next, moving across to the flaps. Flaps at the rear end of the wings, similar to the aileron. See, in this figure I have shown which are the flaps. Now these are used as air brakes when turned down. These are used for increasing the lift on aerofoils. These are powerful, resisting, causing quick drop in flying speed. Tricycle undercarriage. It is a structure to support the aircraft while it is in contact with the ground. It has to perform two major functions. Firstly, to absorb the landing shocks, and secondly, to enable the aircraft to maneuver on ground. Some of the types of tricycle undercarriage are shown in these figures. Now moving across to the last topic, that is aircraft characteristics. Now, aircraft characteristics are prime importance to the airport planner and designer because they must know the following principal aircraft characteristics: type of propulsion, size of the aircraft, weight of the aircraft, wheel arrangement, capacity of the aircraft, the speed of the aircraft, minimum turning and circling radiuses, fuel fillage, jet blast, and noise. Now, type of propulsion. Based on the type of propulsions, the aircrafts are classified under the piston engine, turboprop, and rocket engine. Piston engine, it requires low altitude and moderate speed of around 500 kilometers per hour. Turbojet, a balloon at a speed at 500 kilometers per hour. Turboprop, propeller is provided high altitude speed at 1280 and 2400 kilometers per hour. Rocket, no limit of altitude and the speed will be around 4600 kilometers per hour. Note the size of the aircraft, its circling radius, speed characteristics, weight carrying capacity, noise nuisance, all depend upon the type of propulsions of the aircraft. Now moving across to the size of the aircraft. Now as you can see in the first figure, here we have the numbers, that is 1, 2, 3, 4, 5, 6, noted as 1 is the wingspan. It decides the size of the taxiway apron hangar. Second is the height, which decides the size of the hangar. The third is the fuselage length. It decides the width of the taxiway and the hangar. The fourth decides the distance between the main gears and the gear thread, which decides the turning radius. Number 5 it decides the turning radius, the wheelbase. And lastly, the tail width. Now, what is height? Height, it decides the size of the hanger. Now, see in the second figure, distance between the main gear and the gear thread and the wheelbase. Now, moving across to the turning radius. It is the distance of farther wing tip from the center of rotation used to decide the radius of taxiway, position of aircraft in loading apron hangar. The figure shows the minimum turning radius of an aircraft. Next is the minimum circling radius. There is a certain minimum radius with which the aircraft can take turn in a space. This depends upon the type of aircraft and weather conditions. It is used to design the distance between two airports. Speed of an aircraft, cruising speed or ground speed. It decides the speed of the aircraft with respect to the ground. And lastly, the airspeed. It decides the speed of an aircraft relative to wind. Next is the aircraft capacity, the number of passengers, baggage, cargo, and fuel that can accommodate in an aircraft depends upon the capacity of an aircraft. Next is the jet blast. The aircraft eject hot exhaust gases. The velocity of the jet blast may be as high as 300 km per hour initially. Cause inconvenience to the passengers. It may be a bituminous pavement affected by a jet blast. Lastly, the weight of an aircraft. Now, the weight of an aircraft is influenced by the length of the runway and its structural requirements. In this figure down, you will be able to see that is 1 is considered as passengers, 2 as mail, the 3 as cargo, 4 as fuel, and the 5th as the empty weight. The combined of all the 5 things is known as maximum gross takeoff weight. The combination of all the 5 has the maximum structural landing weight. Now, if we say that is empty operating weight, it means it is an empty aircraft with crew plus all the equipments, excluding the passenger and fuel load, will give you the empty operating weight. Payload, the revenue producing the load, that is 1 plus 2 plus 3, that is the weight of passengers plus the weight of mail and cargo, also known as freight. And lastly, 0 fuel weight. It is the emptying operating weight plus the maximum payload is known as 0 fuel weight. Fuel spillage. At loading aprons and hangars, it is difficult to avoid spillage completely because the bituminous pavements are seriously affected by those fuel spillage. The figure shows you the fuel spillage of an aircraft. Noise. The noise generated by an aircraft creates problems in making decisions on layout and capacity. This noise is of importance in planning and site selection. It is considered advantageous to locate the airport away from the residential area. So here, my friends, this is the introduction to the airport engineering. I hope you may like this video. Do subscribe to my channel for more videos. Thank you.